In lesson 3-2, we'll be estimating square roots. So again, we're going to be thinking about square roots and those perfect squares. Again, 4, 9, 16, 25, 36, 49. Those are our perfect squares again, and we know that um, if we were to take the square root of these numbers, we will get whole numbers for answers. So today when we estimate square roots, we know that the square root of 10 is going to be really close to 3 because the square root of 9 is 3. So when we're doing estimates, we want to try to do this without a calculator, try to figure out which perfect square it's closest to. 10 is closer to 9 than it is to 16. So we know that the answer is going to be closer to 3 than it is 4, because the square root of 16 is 4, but 10 is closer to 9. So we say the square root of 10 is about 3. And whenever you have an equal sign with a little squiggly line over the top, we could say about, or you can say the square root of 10 is about, we can have two squiggly lines, is about 3. So when you want to say is about, you just need to have the two little squiggly lines. So this symbol equals is about, so it means the same. So looking at an example here, we have the square root of 54 to the nearest whole number. Well, what I want to kind of do is think about the two perfect squares that are nearest 54. Well, I have the square root of 49, and then I have the square root of 64. So the square root of 54 kind of fits right in here, but is it closer to 49 or is it closer to 64? So we want to think of the difference between these two and figure out which one's actually closer. Well, 54 to 64 is 10, and 49 to 54, there's only 5 difference. So it's actually closer to the square root of 49. So what we can say here is the square root of 54 is about 7. So if we move um, this screen down, we can kind of see it graphed here, and I'll erase my mark here. And so we can see here a visual of how it is closer to the 7 than it is the 8. So again, estimate the square root of 41.3 to the nearest whole number. Since this is not a perfect square, if we were to actually use a calculator and find the square root of this number, or the previous number, the square root of 54, what you're going to get is an irrational number. An irrational number is one that you cannot write as a ratio. And ratio, remember, another word for ratio is fraction. So if you can't write it as a ratio, we call it irrational, which means we cannot write it as a fraction, which means the decimal never terminates and it never repeats, because if it does repeat, we can write it as a fraction. So here we're just estimating. So the square root of 41.3. So again, think of your perfect squares that are close to that. So we have the square root of 36, and we have the square root of 49. And so the square root of 41.3 fits right in here somewhere. We know that 36 to 41, the difference is about 5. 36 plus 5 is 41. And from 41 to 49, the difference is about 8. So it's just a little bit closer to the square root of 36. So what we're going to say is the square root of 41.3 is about 6. Okay, and so if we want to see that and how it looks on the graph, it's really close to being in the middle here, as you can see, but it is closer to 6. So we will say that it's about equal to 6, because the directions say it wants the nearest whole number. It doesn't want like 6.5 or something like that. In example 3, a real world problem here. If you were to invest $100 in a bank account for 2 years, your investment would earn interest daily and be worth more when you withdrew it. If you had $120 after 2 years, the interest rate, written as a decimal, would be found using the expression okay, quantity, square root of 120 minus 10, and that whole quantity divided by 10. And it says here it wants us to estimate the value, so we'll go ahead and do that. First thing we need to do when we're thinking about estimation is we need to take care of this 120. So square root of 120, well, I know that the square root of 100 is pretty close, and that's 10 times 10. So 11 times 11 is the square root of 121. Well, 120 is really close to 121, and the square root of 121 is 11. So I'm going to say that the square root of 120 is about 11. And so I'm going to rewrite this problem as 11 minus 10 divided by 10. So that's going to be 1 divided by 10, which we know is 0.1. And so it said it wanted the interest rate written as a decimal. So 0.1 would be our interest rate for this problem then, because it says it wants it written as a decimal. And for example number 4, it says estimate the solution of each equation to the nearest integer. The word integer kind of gives us a clue here. If we remember from last lesson that when I find x squared equals 16, I know that x equals not just 4, but positive and negative 4. So here again, we're solving for a squared value. So I don't know if this answer, if this value that we put in for p, I don't know if it's a positive value or a negative value, because I know that whenever I square it, I'm going to get a positive value. So we're looking for the nearest integer. So again, first thing we're going to do is estimate. So I know that p squared equals 6.8. So if I'm thinking about taking the square root of 6.8, I want to think about perfect squares close to 6.8. So I'm going to have square root of 4 or the square root of 9. So I'm only about 2.8 away from 4, and I'm only 2.2 away from 9. So, you know, this is a really close one, but it is actually closer to the square root of 9. So I'm going to say that P is about equal to, positive or negative 3. Because we show here that, you know, the difference between 4 and 6.8 is 2.8, and the difference between 9 and 6.8 is 2.2. So if we were to graph it on a number line, it is closer to the square root of 9, and the square root of 9 is 3. But again, we don't know if it's positive or negative 3, because if you take the square of negative 3, you're still going to get a positive 9. So again, the estimate of the square root of 6.8 is either positive or negative 3. So again, we want to find out what y equals. So we need to take the square root of y squared and the square root of 55. So the square root of y squared is y, and we're going to find the estimate. So y is about, now we'll go over here. We're going to either be the square root of 49 or the square root of 64. So we are only 6 units away from the square root of 49, and we are 9 units away from the square root of 64. So the square root of 49 is closer. So y is about 7. But remember, you look back here, I don't know if it's positive 7 or if it's negative 7, because either way, I'm going to get a positive value here. So I need to say is about positive or negative 7. So what I said right away is that this word integer kind of cues us to the fact that we might have negative answers. So it kind of helps us remember we need to include both positive and negative possible solutions here for our answer. And that is our last example for today's lesson. If you'd like to watch or listen to a couple more examples, you can check out the tutors that I've posted on Moodle. And also be sure to check the homework helper that gives you step-by-step problems for all odd number problems in the book.